Alohe erde ime ofsle, en ye elcomwe, ute our ye erdthe asinle, of ye unit ye orthe. Oink oink. Now, because our last two videos have been a little on the longer side, thanks Mama Volel, I want to jump right into the fire today and see how quickly we can tie up some loose ends connected to our linear equations in standard form. So the title of our lesson, Class 3 of Unit 4, Linear Equations in Standard Form, Part 2. But first, let's take this equation just to make sure we feel really good about graphing. 6x plus 3y equals 0. Let's find a couple of ordered pairs that need to live on our graph and build the graph of our equation. Go! Alrighty, hopefully you paused and did some work, and if you didn't, I hate you. 6x plus 3y equals 0. Now to begin, again, you don't necessarily need to use exactly this structure, but I like to give myself a table where I can keep track of some values of x and y. And in my middle column, again, I often like to include my connector tissue of 6x plus 3y equals 0 to remember how my variables are connected. Now, when we were graphing together, we gave these a fancy name. Remember, where is usually the easiest place to start if I want to find some points? 5, 4, 3, 2, 1. Well, if I want to find some points, the easiest numbers that I can substitute in are 0 for x and y. These give us what we called, again, the intercepts, our x-intercept, which we find by plugging in 0 for y, right? If I'm on the x-axis, I have not elevated up or down. And if I plug in 0 for x, I would get my y-intercept, right? If I'm at 0 for x, I have not gone left or right. I live on the y-axis. So the easiest thing usually to do is to plug in 0 for x and y. Let's start by plugging in 0 for x. If I do that, then I get 6 times 0 plus 3y equals 0. Now to solve for y, all I need to do is simplify. Well, 6 times 0, that's 0. And then I've got 3y equals 0. To isolate y, I should divide both sides by 3. And when I do that, I find that y is equal to 0 divided by 3. 0 divided by anything is 0. Now this tells me that the point 0, comma 0 lives on my graph. What's the fancy name again that we gave this point? 5, 4, 3, 2, 1. This is called our origin, right? So this point, 0, comma 0 on my graph is the place where our x and y axes intercept each other. So 0, comma 0 lives on my graph. Notice here, this point is doing some double duty. Because x and y are 0, it is both our x-intercept and our y-intercept. Cool. With this out of the way then, that means plugging in 0 for y is just going to give me 0 for x. Let's try something else. Maybe I'll plug in a nice friendly number like 1 for x. Again, you are in no way obligated to plug in 1. You can plug in any number that you want for either variable. The idea here is that I'm trying to make my life easier by ideally giving myself some nice small numbers to work with. 1 is a nice small friendly number. And when I plug in 1, right, I simplify, I get eventually here to 3y equals negative 6, divide both sides by 3, and that tells me that y is equal to negative 2. So that tells me that the ordered pair 1, comma negative 2 lives on my graph. That friend is right over here. So I've got 1, comma negative 2. And then again, make my life easy. I want to choose a nice small value to plug in for y. Maybe again I'll pick 1. I could pick whatever I want. It doesn't really matter. So I'll extend my graph a little bit, or not my graph, my chart. So I'm going to plug in 1 for y. So every time that I see y, I'm going to replace it with a 1. Now 3 times 1, that's 3. So 6x plus 3 is equal to 0. Subtract 3 from both sides. That tells me that 6x is equal to negative 3. Divide both sides by 6. Negative 3 over 6 reduces to negative 1 over 2. So that tells me that the point negative 1/2, comma 1 is on my graph. Now negative 1/2 is in the middle of 0 and negative 1. And then I go up to 1 on my y-axis. Here's my point, negative 1/2, comma 1. Now that I've got my 3 points, again, I need at least 3. I'm welcome to put more if I want to. What's the last thing that I need to do? 5, 4, 3, 2, 1. Well, all I've got to do, again, the graph of any linear equation is a line, which means the last thing that I should probably do is draw a line. So I'm going to take my 3 points. I'm going to draw the line that connects them, draw my arrowheads on the ends to indicate that it keeps going, and would you look at that? I've got a graph. Cool! So with this idea in mind, we've hopefully got a pretty firm handle on how to build a graph. 2 quick questions for us to answer. First of all, we've been working with linear equations in standard form, but what if I'm not in standard form? So say, for example, I say to take something like 2 parentheses y minus x equals 8 minus 2y. I want to write this equation in standard form. Real quick, remind me, what does standard form look like? Pause the video, take 10 seconds, look back at your notes. Hopefully you've got it committed to memory. What's standard form? Go. Alrighty, well, hopefully you remember standard form is ax plus by equals c, where these 3, a, b, and c, all of them need to be integers. Remind me, what's an integer? 5, 4, 3, 2, 1. An integer is something without a fraction or a decimal. So it could be 0, it could be a positive number, it could be a negative number. As long as there are no fraction bars or decimal points, then I'm happy. So if I want to rearrange this equation so that I get ax plus by equals c, give yourself 30 seconds. Try the first one on your own. I want to rewrite this equation, rearrange it somehow so that it looks like what I've got in blue. Alrighty, let's try some stuff out. Well, the first thing that I see here that I don't like, I see some parentheses. So a first wise opening move might be to distribute to get rid of those parentheses. So 2y minus 2x equals 8 minus 2y. And from here, notice in standard form, the x and the y are on the same side of the equal sign, and all of the number stuff is on the other side. So what I'm going to do, right, this 8 is totally fine where it is, but I shouldn't have a negative 2y on the other side. So I'm going to add 2y to both sides. When I do that, right, I would get 2y plus 2y equals 4y minus 2x equals 8. And then if I want to be really good and write it in a standard form with the x first, again, using the commutative property, I can rewrite it like this. Negative 2x plus 4y equals 8. Nice. Try it with the one on the right. Y equals 3/5 x minus 2. I want to rewrite this in standard form. Give yourself a minute, pause the video, see how far you get. Go, go, go. Okay, y equals 3/5 x minus 2. So the minus 2 is okay, but the issue here is that I've got a 3/5 x on the right. I want to move it over to the left. So let's subtract 3/5 x from both sides, right? Inverse operations, I want to undo a positive 3/5 x with a negative 3/5 x. So I've got negative 3/5 x plus y equals negative 2. Now, in theory, I'm good, but there is one last thing that's an issue. Remember we said a, b, and c, the coefficients of the variables and the constant on the other side, all need to be integers. So I cannot have a denominator. Well, to get rid of division by 5, one choice that I could make is multiplying both sides of my equation by 5. And if I'm going to do that, right, the entire left side is getting multiplied. Notice I use my parentheses for a reason. Let's distribute. Well, 5 times negative 3/5, that would just be negative 3, right? The times 5 and the divide by 5 words would cancel. 5 times positive y would be plus 5y, and then negative 2 times 5 on the right side is negative 10. So negative 3x plus 5y equals negative 10. Cool. There's our first wrinkle unwrinkled. One last one for the road. So, in standard form, we said a, b, and c can be integers, which means they could be positive, they could be negative, or they could be 0. So what if a or b is 0? Say that I take something like this, y equals negative 1. Notice here the coefficient of x would have been 0, so the x term went away. What would happen here? If I'm saying y equals negative 1, it's a little weird, it's a little wonky, but it is technically in standard form. What does this mean for the equation of my line? Take 30 seconds. Come up with an idea here, a conjecture. What do you think the graph of this might look like? Alrighty, this is weird, so let's try some examples. I'm saying here that y equals -1. So what if I give myself a table of values here where I try to find some points on my graph? So x and y equals -1. Notice if I try to plug something in for y, say I plug in 0 for y, then I would get 0 equals -1. But that doesn't make sense. So plugging in anything but -1 for y actually doesn't help us here. So plugging in values for y doesn't seem to make sense. What if I try to plug in values for x? Well, if x, for example, I plug in 1. Well, if y is equal to -1, notice here that the value that I plug in for x doesn't actually change the value for y. Y is always going to be -1. Say, for example, I plug in 0. Then y would be equal to -1. The value for x that I plug in still isn't impacting me. Y is still going to be -1. Say I plug in something like -2 for x. Well, plugging in -2 for x, I still have the equation y equals -1. There's nowhere for me to put that value of x. -1 is still going to be my value for y. Now, if I plot all of these points on my graph, notice I've got the point 1, -1. That guy's right over here. I've got the point 0, -1. That point is right over here. I've got the point -2, -1. That point is right over here. If I connect those points, what kind of line do I build? Well, notice it's parallel, you might say, to the x-axis, right? It's not going to actually cross through the x-axis. This line is what we call horizontal. So when the x part goes away, what I'm saying is x can be whatever it wants, but the y value, in other words, the elevation, right, how much I go up or down, is always going to be the same. So this, weirdly enough, is going to give me a horizontal line. What do you think is going to happen here if I try to plug in something for x equals 5? Take 30 seconds, same idea. See if you can find some points here. Go. Alrighty, well, let me give myself another chart. So I'm going to say I've got a place to keep track of my x's, place to keep track of my y's, and then my connector tissue of x equals 5. So if I plug in, for example, 0 for y, notice y doesn't have any spot in my equation, so x equals 5 isn't actually going to change at all. X is still going to be 5. If I plug in like -3 for y, something random, x is still going to be 5 no matter what the value of y is going to be. If I plug in 2 for y, x is still going to be 5. It is not impacted at all by the value of y. So if I start to plot some of these points, maybe you arrived at this conclusion already. If x is 5, y could be 0 here. I could have the point 5, -3. So this point down here. I could have the point 5, 2, which would be up here. And if I connect my points with a line, notice here, now I'm parallel to the y-axis. I'm going straight up and down. What I'm saying here is no matter what the value of y is, x always has to be 5. It's not moving left or right. This line instead is vertical. So from this, what I can say is anytime that I see an equation like y equals something, I know that my line is always going to look like what? 5, 4, 3, 2, 1. Well, the graph of y equals something, I'm saying that the height isn't changing. It's not going up or down. So in this case, this will always be a horizontal line through the point C. So in this case, right, if y equals 3, it's going to be a horizontal line through y equals 3. If x is equal to some constant c, instead what I would say rather than horizontal, right, now I'm saying I'm not moving to the left or right. The x value is always going to be the same, so I could move up or down, but I can't move left or right. This is going to be a vertical line through whatever the x value of c is. Fantastic. We'll get some practice doing some more of this in class tomorrow. Again, I'm trying to save you some time here, but exposing you to the fundamental idea. Alrighty, my dears. Take care, be well. I will see you when I see you. Think on this. It's weird, it's wonky, but I promise with practice, it'll make some more sense. Goodbye.